Good morning, students. Today we are going to learn one of the most important topics in the pharmaceutics called the size reduction. So, this topic is very important in pharmaceutical industries because almost every tablet, capsule, suspension, and powder preparations require particle size reduction. When the particle size becomes smaller, what will happen? The surface area will automatically increases. Due to this, the drug dissolves faster and shows a better absorption. Size reduction is also called comminution. So many machines are used in industries for size reduction depending on the hardness and the nature of the materials. In today's class, we will learn the definition, objectives, factors affecting size reduction, and all major equipments used in pharmacy. We will also discuss the principle, construction, working, and uses of each equipment. So, real examples and pharmacy examples will be discussed for easy understanding. At the end of the lecture, students will be able to identify the suitable mills for different pharmaceutical materials. So this topic is very useful in university exams, Viva Voice, and industrial training also. So students, keep your notebooks ready and listen carefully. So let us begin the interesting topic of the size reduction. Definition of size reduction. Size reduction is the process of reducing the large solid particles into smaller particles by applying a mechanical force. So that is the exact definition of the size reduction. So in pharmaceutics, the size reduction is done to improve the drug dissolution, mixing, and formulation quality. So this process is also called as comminution. So the mechanical force may be a compression, impact, attrition, cutting, or shear. Okay. So the different drugs require different methods depending on their physical properties. For example, hard materials require impact or compression methods. So fibrous material require cutting actions. So soft materials require attrition method. So the main purpose is to obtain the uniform particle size here. Okay. So the uniform particles gives the better drug distribution in the formulations. So smaller particles increase the surface area. So increase in the surface area will automatically increase the dissolution and the bioavailability of the product. So size reduction also helpful in the preparation of suspensions and emulsions. So it improves the content uniformity in tablets and capsules. So in herbal preparations, size reduction helps in extraction of the active constituents. So in industries, large scale machines called mills are used for this process. So thus size reduction is an essential operation in the pharmaceutical manufacturing. So the simple definition for students is the size reduction is the process of converting the large particles into the smaller particles using a mechanical force. So the real life examples are grinding coffee beans into a fine coffee powder. So that is one of the example of the size reduction. And the pharmacy examples are reducing the paracetamol crystals into a fine powder for tablet preparation. So like that other preparations also. So let us see the objectives of the size reduction. Students, now let you understand why size reduction is performed in the pharmaceutical industries. So the first objective is to increase the surface area. So when the surface area increases, the drug dissolution becomes faster. So faster dissolution improves the drug absorption in the body. So the second objective is to improve the mixing of the powders. Okay, the first objective is to improve the dissolution, and second objective is to improve the mixing of powders. So uniform mixing ensures the equal drug distribution. Okay, and the third objective is to improve the extraction process. So in herbal medicines, the smaller particles helps in the better extraction of the active ingredients here. Okay, so another objective is to improve the drying process. So smaller particles dry faster than the larger particles. So size reduction also helpful in preparing the suspensions. So smaller particles remains suspended for a longer time. It improves the flow property of the powders. Okay. So it helps in the granulation and the tablet compression methods. So in capsule filling, fine powders fill uniformly. So for that only we will approach this size reduction method. So it also helpful in increasing the reaction rate in some pharmaceutical processes. So therefore size reduction plays a major role in the pharmaceutical manufacturing. So all these are all the various objectives of the size reduction. So let us see the various factors which affect the size reduction. So students, all the materials cannot be reduced easily, isn't it? Yes. So different factors influence the process of size reduction here. So the first factor is hardness. The hardness of the material affects the process of size reduction. It is easy to break the soft material to a small size than a hard material. Okay. And the next factor is toughness. So the crude drugs of fibrous nature are those having the higher moisture content are generally tough in nature. Okay, so a soft but tough materials may present more problem in size reduction than a hard but brittle substances. Okay, and the next one is stickiness. So stickiness also causes a lot of difficulty in the size reduction. So this is due to the fact that the material adhere to the grinding surfaces or sea surfaces of the mill. Okay, so it is difficult to powder a drug of having a gummy or a resinous nature. So if the method used for the size reduction generates heat, so complete dryness of the material may help to overcome this difficulty. So overall the stickiness can cause a lot of difficulty in the size reduction. Material structure. So materials which shows some special structures may cause problems during size reduction. Example, vegetables drugs which have a cellular structure generally produce a long fibrous particles on its size reduction. So similarly a mineral substance having a lines of weakness produces a flake like particles on its size reduction. Okay, and coming to the moisture content, so the presence of the moisture in the material influence a number of its properties such as hardness, toughness, thickness, so which in its turn affects the particle size reduction here. Okay, so the material should be either dry or wet, so it should not be damp. Okay, so the materials having 5% moisture in case of dry grinding and 50% moisture in wet grinding does not create any problem. Okay, and softening temperature. So waxy substances such as stearic acid or drugs containing oils or fats become softened during the size reduction process. So if heat is generated, so this can be avoided by cooling the mill. Okay, and purity required. So various mills used for size reduction often causes the grinding surfaces to wear off and thus impurities come in the powder. So if a high degree of purity is required, such mills must be avoided. So moreover the mill should be thoroughly cleaned between batches of different materials in order to maintain the purity. Okay, so the purity is also one of the factor. Physiological effects. So some drugs are very potent, so during their particle size reduction in a mill, so the dust is produced which may have an effect on the operator. So in such cases the enclosed mill may be used to avoid dust. Okay, ratio of feed size to product size. So to get a fine powder in a mill, it is required that a very small feed size should be used. So hence it is necessary to carry out the size reduction process in a several stages, so using different equipments. Example, preliminary crushing followed by coarse powders and then fine grinding. So like that we have to adopt the method. And next one is bulk density. So the output of the size reduction of the material in a mission depends upon the bulk density of the substance. So that is also a factor needed to be considered while doing the size reduction. So all these are all the various factors which affects the size reduction. And next we will see about the methods of size reduction. Methods of size reduction. So students, different methods are used for size reduction depending upon the nature of the material. So the first method is compression. So in this method the material is crushed between the two surfaces. The second method is impact. So in impact method the particles are broken by sudden force. The third method is attrition. So in attrition particles are reduced by rubbing actions. The fourth method is cutting. So cutting is used for the fibrous materials. So shear force is applied using in a sharp blades. Sometimes a combination of methods is also used. For example, hammer mills uses impact, ball mill uses impact and attrition. So cutter mill uses cutting action only. Roller mill uses compression. So the selection of the method depends on the hardness and the structure of the material. So the process should produce a uniform particle size only. So the method should avoid contamination and the heat generation. So proper method selection improves the product quality here. So thus understanding the method is very important in the pharmaceutics. So we will see one by one clearly. So the first method is cutting. So the material is cut on a small scale by means of sharp blades with knives, root cutters or any other sharp instruments. So on large scale a cutter mill is used. So the cutting of the drug is usually done to hasten the drying of the drugs. Okay. So we will see about the cutter mill here. So what is the principle involved in the cutter mill means the cutting mill works on the principle of cutting. So the sharp blades cut the material into small pieces here. So let us see the construction here. So the machine contains a horizontal rotor. Several sharp knives are attached to it and stationary knives are also present. A feeding hopper and a discharge screen are provided. So the chamber is completely enclosed. So working. So the students, so let us see the working of this cutter mill. So students, the cutter mill is mainly used for the fibrous materials only. So the material enters to the hopper, the rotor rotates at a high speed here. So the moving knives passes near stationary knives. So this provides the cutting action. So the material breaks into a small pieces here. So the particles passes to the screen. The machine gives a controlled particle size here. So the fibrous materials are difficult to grind by impact. So therefore cutting action is preferred. Okay. The machine operates continuously. Heat generation is very less, so the equipment is easy to maintain. It is widely used in the pharmaceutical industries. Thus cutter mill is suitable for fibrous drugs. Okay, so let us see the uses of this mill. So it is mainly used for fibrous crude drugs, so used for roots and leaves. Okay, so what are the advantages of this method means it is highly suitable for fibrous materials, continuous operation, low heat production. So what are the disadvantages means it is not suitable for hard materials, blade wear may occur. Okay, so what are the real life examples means cutting vegetables into a small pieces. So imagine the same thing, this is the mechanism which is happening in the cutting mill. Okay, and the fancy examples are cutting senna leaves and herbs. And the next method is compression. In this method the material is crushed by the application of pressure. On small scale, the size reduction is carried out by using piston and motor, whereas on large scale, roller mill is used. Roller mill. So what is the principle of this roller mill means the roller mill works on the principle of compression here. So the material is crushed between the rotating rollers. So that is the main principle of this mill. And coming to the construction, the machine mainly consists of two heavy rollers. The rollers rotate towards each other. A hopper is present above the rollers. A discharge outlet is present below. The distance between the rollers can be adjusted. Okay, so the rollers may have smooth or corrugated surfaces. Okay, Working. Students, now let us understand the roller mill. So the material enters through the hopper. The rotating rollers pull the materials between them. So the compression force is applied. The particles break into a smaller pieces. So observe the diagram here. So the reduced material comes out through the bottom. So the particle size depends on the gap between the rollers. Okay, so we can adjust it. Similarly, a smaller gap produces a finer particles here. The machine is used for coarse grinding only. So the roller mill produces a less heat. So it gives a uniform particle size. So the machine is simple and efficient. Okay, so it is suitable for brittle materials. So continuous operation is possible. So thus roller mill is an important compression mill. Okay, so what is the use of this mill means? It is used for crushing the seeds and grains. So used in pharmacy for coarse materials. So advantages means it is simple construction, low heat generation, uniform particle size. So the size achieved here is uniform in nature. Okay, disadvantages. So it is not suitable for sticky materials, so cannot produce very fine powder. Okay, so those are the disadvantages. So real life example is, so crushing wheat into a flour. So that is the real life example. So how compression will happen. Okay, here the rollers number will possible to increase. So triple roller mill is also there. So at that mill we can use 3 rollers at a time to crush the materials. Okay, and next one is hammer mill. Principle: hammer mill works on the principle of impact. Okay, the material is broken by rapidly moving hammers here. Okay, so observe the diagram. So here are the hammers. Okay, let us see the construction of this mill. So hammer mill consists of a steel chamber. Inside the chamber a rotor is attached. So several swinging hammers are connected to the rotor. Okay, a screen is present at the bottom, and the machine also contains a feeding hopper and a discharge outlet. So the rotor rotates at a high speed here. Okay, so this is about the construction. Let us see the working. So students, now let us understand the working of the hammer mill. So the material is introduced through the hopper. So the rotor starts rotating at very high speed. So the swinging hammers strike the particles. So due to impact force, the particle breaks into a smaller pieces. Okay, so observe. The reduced particles passes through the screen. So oversized particles remains inside until further grinding. Okay, finally the fine powder is collected through the outlet. Okay, so the particle size depends on the screen size and rotor speed here. So the machine is suitable for brittle materials only. Okay, heat generation is less compared to some mills, and hammer mill produces a uniform particle size, and the operation is continuous and very fast. Okay, so the machine is widely used in the industries. So thus hammer mill is an important impact mill. What are the uses of this mill means? Used for size reduction of dry materials, used in pharmaceutical powder preparations, used in the food and the chemical industries. So what are the advantages of this mill means? It has a high production capacity, continuous operation, easy to clean, uniform particle size. Disadvantages means not suitable for sticky materials, produces some noise and dust. Okay, so what are the real life example of this type of mill means? Grinding spices into powders. Okay, and pharmacy example is grinding crude drugs for herbal formulations. Okay, so this is about the hammer mill. And next is disintegrator. Principle: the size reduction in disintegrator is done by impact. So let us see the construction. It consists of a steel drum having a shaft in the center. So the shaft contains a disc on which 4 beaters are fixed. So the shaft rotates with a speed of 5000 to 7000 revolutions per minute here. So the side and the upper inner surfaces of the drum is rough and undulating. So the lower part of the drum has an detachable screen or sieves. So the sieve has a definite pore size here. Okay, so this is about the construction. So coming to the working, the beaters are mainly responsible for grinding but are helped by undulations of the inner surface and roughness of the drum. So the material is fed to the beaters through hopper which is fitted to the drum, and the material is broken into small pieces by impact of the beaters here. So due to the high velocity of the beaters, the air velocity inside the chamber is increased, and the air is allowed to pass through an inlet on which the dust bag is tied, so which retains the fine particles of powder here. Okay, so here the beaters are highly helpful for size reduction. Okay, and coming to the uses, the mill is used to powder all types of drugs including very hard drugs. So the drug should be dried before feeding into the disintegrator to get the fine powder here. Okay, so to avoid the jamming of these beaters of the disintegrator, use moderately small pieces. Okay, so and the next method is attrition. So in attrition, pressure is applied on the material as in compression, but the surfaces are moving relative to each other, so resulting into a shear force which break the particles here. So on laboratory scale, the size reduction by attrition is done by using a pistol and mortar, but on a large scale, roller mills can be used. Okay, and the next type of method is combining the impact and attrition. Okay, so the mechanism of impact and attrition can be combined in the mill to get the better result. So the following are the mills in which the size reduction is done by impact and attrition. Those are ball mill, fluid energy mill. So we will see about the ball mill now. So ball mill, so principle of this mill is the ball mill mainly works on the principle of impact and attrition, we already discussed. So the balls inside the rotating chamber produces the grinding action here. Okay, construction. The ball mill mainly consists of a hollow cylindrical shell. The shell rotates horizontally, so inside the shell steel or a porcelain balls are placed. So the chamber contains an inlet and an outlet, and the shell may be made of metal or porcelain. So the balls occupy about 30 to 50% of the volume here. Okay, so let us see the working. Students, now let us understand the working of the ball mill. The material to be ground is introduced into the chamber, and the chamber rotates around a horizontal axis here. So as the shell rotates, the balls moves upwards, then the balls falls downwards on the material, so this produces the impact force. So at the same time, the rubbing between the balls produces the attrition also, so thus the particles becomes smaller in size. So the fine powder is obtained after continuous rotation of this mill. Okay, so the speed of the rotation is very important here. Very high speed prevents the proper grinding. Okay, so ball mill can be used for both wet and dry grindings, so it produces a very fine powder. So the machine is useful for toxic materials because it is highly enclosed one. Okay, so thus ball mill is widely used in pharmacy. Uses means it is mainly used for fine grinding, used for toxic materials, used for preparation of ointments and suspensions. So advantages are produces a very fine powder suitable for wet and dry grinding, closed system, reduces the contamination. Disadvantages means it is a slow process, a high energy consumption, and not suitable for sticky materials. So real life examples are grinding paint pigments. Okay, and a pharmacy example is fine grinding of antibiotics and suspensions. So what are the points needed to remember about this mill means features like the main principle of this mill is impact and attrition. Here the grinding media is steel balls, and the grinding type is wet and dry, and the product is fine. Okay, so that is the product, final product we get here is the fine powder. Okay, and next one is fluid energy mill. So fluid energy mill mainly works on the principle of impact and attrition using in a high velocity air. So construction of this mill is like this. So the machine mainly consists of a circular chamber. Compressed air enters through the nozzle. The chamber contains non-moving parts. So a classifier is attached and a fine particles leaves through outlet. So the large particles remains for further grinding. Okay, so this is about the construction. So observe the diagram clearly here and working. Students, fluid energy mill is also called the micronizer. So compressed air enters through the nozzle at a very high speed. The material is fed into the chamber. So the particles collide with each other. So due to impact and attrition, the particles become very fine here. Okay. So the centrifugal force helps the classification here. Okay. So the fine particles move upwards and are collected. Okay. The large particles remains inside for further grinding. So the machine produces extremely fine powder here. So it is suitable for heat sensitive materials. Since no moving parts are present, so contamination is very less. The machine is expensive. It consumes high energy. So however, it is very useful in advanced pharmaceutical industries. So thus fluid energy mill is important for micronization. Okay, so what is the main use of this mill means it is used for antibiotics and steroids. So used for heat sensitive drugs, used for ultra fine grinding. Okay, so advantages means it mainly produces a very fine particles suitable for heat sensitive drugs and a less contamination. So all these are all the various advantages, and disadvantages means it is very expensive equipment and a high energy consumption. Okay, so what are the features needed to remember about this mill means it mainly works on the principle of impact and attrition, and the grinding media is high velocity air. Okay, and the product is ultra fine nature, and the uses of this mill means it is used for heat sensitive drugs. And the next mill is edge runner mill principle. Edge runner mill mainly works on the principle of crushing and attrition. So both the crushing and attrition will simultaneously will happen in the mill itself to achieve the size reduction here. Construction. The machine mainly consists of a heavy stone or a metal wheel. The wheel rotates in a circular pan. A scraper is attached. The pan contains the material. The wheel may rotate around its own axis. So all these are all the construction features of this mill. Working. Students, edge runner mill is used for wet grinding. So the material is placed in the pan. The heavy wheel rotates over the material. The crushing and rubbing actions occur simultaneously here. The particles become smaller. The scraper mixes the material continuously, so uniform grinding occurs. Okay, so the machine is used for ointments and pastes. So wet massing can also be done. So the equipment is very simple. The process is comparatively slow. So large scale production is difficult. Okay, so however it gives a smooth and a uniform paste. Okay, thus edge runner mill is useful for semi-solid preparations. Advantages: uniform grinding suitable for wet materials. Disadvantages: slow process, large space required. Pharmacy example is preparation of medicated ointments. Okay, applications of size reduction. Students, now let us discuss the pharmaceutical applications. So size reduction is used in the tablet manufacturing. Fine powders mix uniformly in a tablet formulations. So it is used in the capsule filling. So smaller particles improves the filling accuracy here. So suspensions require a small particle size. So fine particles remain suspended for a longer time. Okay, and ointments requires a smooth powders. So herbal extraction becomes more efficient here. So antibiotics are micronized to improve the absorption. So in inhalation therapy, ultrafine powders are highly needed, and the cosmetics also use the size reduction. So food and the chemical industries use the same principle. So the modern pharmaceutical industries depends heavily on the milling operations. So thus size reduction is one of the most essential unit operations. Okay. So size reduction is a highly important unit operation for different doses ones. So as we observe here, so for tablets, size reduction is required for uniform mixing. For capsules, a better filling. Suspension, stability. So ointments, smooth texture. So inhalers, a better lung delivery. So all these are achieved only through size reduction of the particles. Okay, so that much importance is there for size reduction. Okay, advantages of the size reduction: improves dissolution, improves absorption, improves mixing, improves extraction, improves product quality. So helps suspension stability, improves drying efficiency, so enhance the reaction rate. So all these are all the various advantages of this size reduction. Disadvantages: produces dust, heat generation may occur, contamination may occur, equipment wear and tear, so may produce the electrostatic charge. Some drugs degrade due to heat. So students, every process have advantages and disadvantages. Size reduction improves dissolution and bioavailability, so it gives a better formulation quality. Okay, so however the excess grinding may produce heat, so heat sensitive drugs may degrade. Dust formation may causes contamination. Industrial workers require the protective equipment here, so proper mill selection reduces the disadvantage obviously. So cooling arrangements sometimes used. Okay, so therefore industries should maintain the suitable conditions. So thus understanding both advantages and disadvantages is important. General characteristics of the various types of mills are given in the table here. So here is a small table, so try to by heart this table properly. So here the first type of mill is the cutting mill. For this action is cutting, and the product size is 20 to 80 mesh, and it is suitable for fibrous and crude drugs and not suitable for friable materials. Okay, and second one is roller mill. Action is compression. Product size achieved is 20 to 200 mesh, used for soft materials and not suitable for abrasive materials. Third one is hammer mill. Action is impact, and the product size achieved is 4 to 325 mesh, used for almost all drugs, not used for abrasive materials. Disintegrator. Here the action is impact, and the product size is 20 to 80 mesh, used for almost all drugs including very hard drugs. Okay, and not suitable for soft and sticky materials. Okay, so by heart all these things like this. And fifth one is the ball mill. Here the action is attrition and impact. Product size is 20 to 200 mesh, uses brittle drugs. So it is highly suitable to grind the brittle drugs and not used for soft materials. And finally hedge runner mill. So here the action is crushing and shearing, and the product size achieved here is 20 to 80 mesh. It is used for the almost all drugs and not suitable for sticky materials. Okay, so by heart this table, it is very important. Selection of degree of size reduction. So the image explains how different levels of size reduction are selected in the pharmaceutical industries based on the required final particle size. So the type of the mill and the pharmaceutical applications. So it shows 5 stages of the particle size reduction, from coarse particles to the ultra fine particles. So each stage requires a suitable grinding equipment depending on the desired final size and use of the product. So the first one is the coarse reduction. So the particle size is 5 to 20 millimeters. So suitable mill here is cutter mill. So in coarse reduction, a very large particles are converted into a small coarse particles here. So the final particles are still comparatively large. So this process is mainly used for crude drugs and fibrous materials. Cutter mill is preferred because the fibrous materials requires cutting action. Okay, so the process is usually the first stage before the final grinding. So pharmacy examples are cutting dried roots, stems and leaves in a herbal drug preparations. The real life example is cutting vegetables into small pieces. Okay, so same mechanism here we are using. And the second one is the medium reduction. The particle size is 500 micrometers to 5 millimeters. So suitable mill is roller mill. So in medium reduction, the particles becomes smaller than the coarse reduction. So the roller mill works on compression principle. So this stage is useful for soft materials and herbal drugs. So the process produces moderately fine particles here suitable for further processing. So heat generation is less in roller mills. Okay, so that's how we will prefer this roller. Pharmacy example is crushing herbal materials before tablet preparations. Okay, and next one is fine reduction. So the particle size is 100 to 500 micrometers. Suitable mill is hammer mill. So the fine reduction produces the small powder particles used in the pharmaceutical formulations. So the hammer mill works on the impact principle. So rapidly moving hammers break the particles into the fine powder here. The size range is commonly used for tablets, capsules and powders. So uniform powder size improves the mixing and the drug distribution here. Okay, and next is very fine reduction. So the particle size range is 10 to 100 micrometers. It is a suitable mill for this to achieve this type of reduction is ball mill. So very fine reduction produces extremely fine particles here. So the ball mill works on the impact and attrition principles. So steel balls inside the rotating chamber reduces the particle size. So this process is used for poorly compressible materials and fine powders. So very fine powders improves the dissolution and absorption obviously. Okay, and next one is ultra fine reduction. So the particle size range is 1 to 10 micrometers. So suitable mill here is fluid energy mill. Okay, so we will achieve this size. So we will achieve this size of particle size only through the fluid energy mill. So okay, so ultra fine reduction produces the micronized particles here. The fluid energy mill uses high velocity air streams for grinding and the particles collide with each other and becomes extremely fine. So okay, this process is used for special pharmaceutical applications. So micronized drugs shows better absorption and the lung delivery. So all this is achieved through the fluid energy. So this image clearly shows that so different particle size requires different mills. Okay, the selection of the mills depends on required final particle size and the nature of the material intended pharmaceutical use. So as the particle size becomes smaller, what will happen? So energy resistant increases, equipment becomes more advanced and the surface area increases. So the dissolution rate obviously improves. Okay, so therefore the pharmaceutical industries carefully select the degree of size reduction for better product quality and the efficiency here. Okay, lavigation. So lavigation is the process of wet grinding. So the material is converted into a paste with water and then grinding of the paste is done in a mortar here using a flat headed pastils. Okay, so in case of large scale grinding, it is done by using colloidal mill or a mill resembling an edge runner mill. Okay, so the process is used for preparation of light kaolin, chalk, red and yellow mercuric oxide, calamine and camphor, like that. Okay, so after the process of lavigation, the paste obtained contains some fine particles along with a small proportion of coarse particles. Okay, so the fine particles are separated from the coarse particles by the process of elutriation. Okay, so we will see that one also. So next one is elutriation. So alliteration is the process of separation of the fine particles and the coarse particles from a paste obtained after lavigation. Okay, so how we will achieve this separation means the paste is mixed with a large volume of water and the mixer is allowed to stand for a short period of time, so during which the heavy coarse particles with high density settles on the bottom of the vessel like suspensions. So the fine particles with low density remain suspended in the upper layer of the liquid. Okay, the upper liquid is poured off and the fine particles are allowed to settle down on the bottom. Okay, so the wet paste containing the fine particles is then dried. Okay, so later we have to collect the settled content and then we will dry. Okay, in small scale grindings a conical flask can be used, but on large scales alliteration tanks are used. Okay, so that's all about the lavigation and alliteration methods. So here are some interactive questions for students that we will get this type of questions from this chapter, that what is size reduction, what is the another name of size reduction, which mill works on the impact principle, which mill is used for fibrous materials, which mill produces the ultrafine powders, so what is the importance of the size and the surface area, and why are the heat sensitive drugs difficult to grind, and which method is used in a cutter mill, so what are the advantages of the ball mill, so why is size reduction important in the suspension. So like that we will get the questions from this chapter. So here is some small activity for the students, that identify the suitable mill for the following materials like heads, antibiotics, wheat grinds, ointment mass, fibrous leaves, like that. Okay, some Viva questions are also there here, that define the communication, explain the hammer mill principle, write the advantages of the fluid energy mill, so differentiate the ball mill and the hammer mill, so what are the factors affecting the size reduction. Like this we will get questions. Okay, conclusion. So students, we are learned the complete topic of the size reduction today. So we understood the definition and the objectives, we discussed the factors affecting the size reduction, we studied the different methods like impact, compression, attrition and cutting. So we learned the construction principles, working and uses of the all major mills. Hammer mill is used for impact grinding, ball mill is used for fine grinding, roller mills works on compression, cutter mill is used for fibrous materials. So Fuji mill produces the ultrafine particles, edge runner and end runner mills are used for wet grinding. So size reduction is very important in the pharmaceutical industries. This topic is frequently asked in the examinations and Viva. So revise the comparison tables carefully, practice the diagrams and principles regularly. With the proper understanding you can easily answer the university questions. Thank you students for listening carefully. If you enjoyed today's lecture on size reduction in pharmaceutics, so please revise the notes again for better understanding. Practice the tables and principles regularly. Share this lecture with your friends and classmates. So keep learning pharmaceutics in simple and easy way. For more pharmacy lectures, pharmaceutical engineering topics and Viva explanations, stay connected. Thank you for watching and attending the class. See you in the next interesting pharmacy lecture. Study well and keep smiling.